In this lesson, we'll do some practice questions to illustrate the use of cosine ratio to solve problems related to right angle triangles. Let's get started with triangle ABC, in which two sides of the triangle are given. The side opposite to 90-degree angle, which is at vertex B. The side opposite to vertex B is hypotenuse. So let's label this as hypotenuse. And if the angle under consideration is at vertex A, then the side opposite to vertex A would be opposite, and the remaining side is adjacent. It means for the triangle ABC, we know what is hypotenuse and we know what is adjacent. So let's define cosine ratio of the angle X. Cos X is equal to adjacent over hypotenuse, and cos of X is equal to, just substitute the values of adjacent and hypotenuse, those would be 7 over 10, means cos of X is equal to 0.7. When the ratio cos of X is known, we can make use of calculator and we can find out the angle X by taking cos inverse of 0.7. So cos inverse of 0.7, and this will give us the value in degrees, that is equal to 45.57 degrees. For better accuracy, we can round it off to the nearest tenth and make it 45.6 degrees. So this is the angle at vertex A, and now we can find out the angle at C. The angle at C is simply the complementary angle of angle at A. Therefore, angle at C would be equal to 90 minus 45.6 degrees. This angle will become 44.4 degrees. So now all the three angles in the triangle are known, and the only side which is unknown is the side BC. Once this angle is known, 44.4, we have two options. Either we can apply cosine ratio at angle C and find out the opposite, or we can use Pythagoras theorem to find out the third side of the triangle. For this lesson, we will be using Pythagoras theorem, and in next lesson we will use cosine law to find out the second side. So if we use Pythagoras theorem by using Pythagoras theorem, what we have is AC square. AC square is equal to AB square plus BC square. Because we want to find out the value for BC, therefore BC must be isolated on one side, and by isolating BC on left side, we will get AC square minus AB square. And now if we substitute the values of AC and AB, we will get, this is 10 square minus 7 square equal to BC square, and BC square now will become 100 minus 49, and 100 minus 49 will give us BC square equal to 51 and BC is equal to 51 square root, and this gives us the value for BC equal to 7.14. 7.14. So this is how we get BC. Once we have this side, then we can see that all the three sides and all the three angles of the given right angle triangle are known. So the triangle is solved for all of its 6 elements. In next triangle, let us name the triangle first and name it as A, B and C. Angle of 90 degree is at C, therefore the side opposite to C is the longest side and it is hypotenuse. And apparently we are required to find the hypotenuse. And for finding hypotenuse, we can define the ratio, cosine ratio of 65 degree angle in right angle triangle ABC. For hypotenuse, cosine of 65 degree is equal to adjacent over hypotenuse, and cos of 65 degree is equal to adjacent is 4.5 centimeter, 4.5 centimeter, but the hypotenuse is unknown, so we just substitute with the symbol C. Therefore C is equal to 4.5 divided by cos of 65 degree, and this will give value of C equal to 4.5 divided by cos of 65 is 0.42, and this gives the value of C equal to 10.7 centimeter, or whatever is the unit of measurement. So here, if C is equal to 10.7, then for solving the triangle, the angle at B is the complementary angle of angle at A. Therefore, we can simply subtract from 90 and we will get the angle at B, which is equal to 90 minus 65 degree, and this is 25 degree angle. This way all the three angles in the triangle are known and two sides are known. For third side, either we can define cosine ratio of 25 degree and find out the side BC, because if we take cosine of 25, then BC will become the adjacent and the hypotenuse is already given. But in this lesson, we will make use of Pythagoras theorem to find out the missing or unknown side. So by using Pythagoras theorem, the hypotenuse square is equal to adjacent square plus opposite square, and hypotenuse is 10.7 square equal to adjacent is equal to 4.5 square plus opposite is BC for the angle under consideration 65. So this is BC, and now let's isolate BC on one side. So BC square would be equal to 10.7 square minus 4.5 square, and this will give us BC equal to 10.7 will become 114.49 minus 4.9 is equal to 20.25, and this way this is value for BC square, and BC is equal to 94.24, and if we take square root, this will give us 9.70. This way we have solved for all the 6 elements of the right angle triangle.